Hey guys, welcome back to my channel. Today we're diving into logistic regression, a fundamental concept in AI for classification problems. So, what is logistic regression? Logistic regression is used when the outcome of our AI model is a category, like yes or no, win or lose, or pass and fail. It's similar to linear regression but tweaked to work with categorical outcomes instead. Because instead of a continuous line, logistic regression gives us a probability curve. This curve helps us decide which category a data point belongs to. In logistic regression, we use a special function called the sigmoid function. It converts any input into a value between 0 and 1, representing a probability. For example, if we're predicting whether a team will win or lose based on their performance, logistic regression will tell us our probability of winning. 1 means that they will win, and 0 means that they're going to lose. Then we're going to decide the cutoff point, like 0.5, to classify the outcomes. Above 0.5 means win, and below means lose. Let's jump into Python and start coding. We'll use a dataset, let's say lung cancer in a group of patients. And so first, let's import all the libraries that we're going to need. For a more in-depth explanation of numpy, pandas, and matplotlib, be sure to check out my video on setting up the AI environment. We'll also be using several tools from scikit-learn, which is a library we'll use to train our model. All of this code will be on my GitHub in the description, so be sure to check that out. We'll also be mounting everything onto our Google Colab, everything in our drive onto a Google Colab, just like in the linear regression video. So let me run this to get all of our libraries going, and then I'm going to mount all the content from my drive into my Google Colab. So now we're going to use pandas to read our dataset, which is in the form of a CSV file, and we'll convert it to a data frame. By the way, if you want to follow along with the dataset, I have a link to the Google Drive file in the description as well. So if you copy that to your drive, you can mount it on your notebook as well, and you can work with it. We're using the head method to see the first 5 rows of the dataset, and as you can see, there are many columns, but the dataset also has like data that's a little bit clunky. So to fix this, we'll be doing something new today called preprocessing. Data preprocessing means that we'll get our data ready so we can work with it and not have any problems in training the AI model. First, we'll get rid of missing values with the drop NA function, and then we'll convert the gender and the lung cancer columns into values of 0 and 1 so we can better visualize it with the sigmoid probability function I mentioned earlier. Now, the final part of preprocessing will be to balance out the dataset. As you can probably tell if you look closely at the dataset file, there are significantly more people without lung cancer. Here, we will be balancing that out so that the AI won't get biased towards a certain result and make predictions for the wrong reasons. We can do this with the resample function, which lets us upscale the minority values to the same level as the majority values. Now, as you can see, we have a 50-50 split, so they're equal. This will make it much easier for us to understand logistic regression. Now, we need to define our x and y values. Our x value should be the input, which in this case is everything except the lung cancer column. This includes the symptoms, gender, age, and smoking habits. We can retrieve this data by accessing the data frame once we drop the lung cancer values because those belong to the y-axis. Our y column, which is the output that we're measuring, will tell us whether or not the patient has lung cancer. The AI will then try to predict this and will later measure how accurate our model actually is. So now for the fun part, let's split our data into 2 sections, a training section and a testing section. We'll use the train test split function from scikit-learn to divide our data into values that we will feed to the AI model so that it can understand our dataset, as well as testing data which the model will use to actually predict whether or not the patient has cancer. Think of it like this. Let's say you have a very important math exam coming up. The training data is all the homework, notes, and studying that you're doing to learn about the math topic and prepare for the exam. The testing data can be thought of as the actual exam, which will now test how well you know the subject. Your responses to the math problems are the predictions, and your score on the exam is the accuracy of your brain's model. Pretty cool, right? But instead of evenly dividing the training and testing data, we're going to do a 80% and 20% testing split so that we can train the model as much as possible while still leaving room for the test values. So when we run that, all of our variables have been initialized. Now, we'll use the logistic regression function from scikit-learn to create our model. Then, just like in linear regression, we'll use the fit function to train our model on the training data, which is the same 80% that we split from our main data set. After this, we'll use the prediction method to make our model predict whether or not the patients have lung cancer based on the X values of our training data, of our testing data. Then we'll use the accuracy score function to compare the model's predictions with the actual number of lung cancer patients to see how well our AI has done. As you can see here, our model scored a 0.88 from a scale of 0 to 1. This means that it has an 88% accuracy rate. Even though it may not be perfect for actually predicting lung cancer, this is still the most basic form of classification, and there are many ways to improve here. Regardless, what's fascinating is that the model was able to understand how these symptoms relate to the cancer results, and it learned from the data that was able to decide whether or not the patient has lung cancer. This is why we call it machine learning, because our machine has learned and understood and practiced just like our minds do. Human minds have natural intelligence, but we can also create our own artificial intelligence that mimics our minds. That's where those two terms come from. Now, we can finally visualize this using matplotlib. We'll use numpy to sort the model's predicted probabilities, and then we'll use matplotlib to graph the actual outcome. This way we can peek into the model's thought process and understand why it marked some cases as lung cancer and some as no lung cancer. I hope this video helped teach you basic logistic regression in Python and how it can be used in real-world scenarios. If you're really interested in AI predictions, you should go ahead and watch my video about linear regression and compare the two types of regression and share what you learned in the comments. That was it for this video, and don't forget to smash that like button, subscribe to my channel, and share this video with your friends. I'll see you in the next one.